Okay, in this video we're going to talk about finding x-intercepts of polynomials. Now, if you recall, an x-intercept is the value of x when y is equal to 0, and that is because it's where it crosses the x-axis. So some things about polynomials, when we try to find the x-intercept, if it's using function notation, even though we don't write it as y, we know that this is function notation, but this represents our y, or our output. So what I'm doing is I'm replacing that function notation that we assume is y with 0. And now we want to solve for x. So if I look at this is already set up very nicely for me where it's factored. And one of the ways that we can solve polynomial equations that we found in a previous section was by factoring. So I can find that my x-intercepts are -5, -2, and 4. So those are all the places that it crosses the x-axis. So for this one here, the next one, we need to factor it. So a quick review, if you recall, the difference of cubes is the formula for that. To factor that, it would be a minus b, and then it would be a squared plus ab plus b squared. So there's our formula for the difference of cubes. And so we just have to identify what our a and b values are. So if we have x cubed minus 125, my a is going to be x, right? X cubed is a cubed, so x is a. And b is going to be 5, because I can rewrite 125 as 5 cubed. So that would be my b. So all I would have to do then is go ahead and replace this in my formula to factor. So I would have a, which is x, minus b, which is 5, times a squared, which would be x squared, plus a times b, which would be 5x, plus b squared, which is 5 squared, which is 25. Now, this can't be factored anymore over the reals. If you don't recognize that right off the bat, and you try to factor it, you're going to find that you can't. But then if you try to take it further and you plug that into the quadratic formula to find those values, you're going to find that this gives us complex values, or complex numbers. So they're not going to be real. And only the solutions to an equation when x set equal to 0, only those values of x that are real are going to be the x-intercepts. So the only x-intercept I have here is going to be 5, since these yield imaginary numbers. Okay, and then in this last example, again, we have to factor. Since I see 4 terms, bells go off in my head, and I think, oh, I should try grouping. So I'm going to group the first 2 together and the second 2 together, and I'm going to pull out what the first 2 have in common. And the first 2 have a common 2x, so that leaves me with x plus 4. And when you do factor by grouping, you want to make sure that these 2 factors come out exactly the same. So we need to figure out what goes in front of that second parentheses so that those come out exactly the same. So what times x plus 4 would give me 3x plus 12? That would have to be a plus 3. So if I pull a 3 out of this, I'm left with x plus 4, so that works. So now I have these 2, x plus 4, in common, and I'm left with 2x plus 3. And if this is set equal to 0 for my h of x, then I can see that my x-intercepts are going to be -4 and -3/2, because I want to solve each of those mini equations set equal to 0. So if I were to graph this on my calculator, Where it would cross the x-axis would be at x equals -4 and x equals -3/2.